Okay, expanding brackets. A basic mathematical skill. GCSE grade E up to around about grade C, depending on what you've been asked to expand. Bread and butter skill for A level. You have to be able to do it. So I'm going to quickly go over a couple of the more common written methods for doing this. I'm sure you've come across it before, but if you can't remember how to do it, or it's been a long time since you've had a look at it, maybe this will act as a nice little reminder for you. So we're going to start with 3 lots of x plus 2y. What this means is 3 lots of x and 3 lots of y. So 3 lots of x gives me 3 lots of x, and 3 lots of 2y gives me 6y. So if we expanded it, we've taken our expression consisting of 2 factors, a 3 and x plus 2y, and expanded it into a expression involving no factors. Okay, Fastball method. Another method commonly taught at GCSE is to think of it in terms of a rectangle, where our numerical factor outside the bracket is going to be the width of the rectangle, and our factor inside the bracket, in this case x plus 2y, is going to be the length of the rectangle. So if we look at the rectangle, the left-hand rectangle within the rectangle is going to have an area of 3 times x, so 3x, and the right-hand rectangle is going to have an area of 3 times 2y, so 6y. So once again, our 3 lots of x plus 2y gives us 3x plus 6y. Okay. Now our second example, minus 2 lots of 2x minus 3, is very similar. So minus 2 lots of 2x minus 3. I can expand in exactly the same way as I last did. So we're going to have minus 2 lots of 2x, so minus 4x. Sorry about changing pen colour. And minus 2 lots of take away 3, or so if I multiply 2 negatives, I get a positive, so plus 6. And I can do that in exactly the same way as I did on the right-hand side over here for the rectangle. Although, conceptually, there's a little bit of difficulty here because I'm going to have a width of minus 2. And clearly, we can't actually have negative length. Similarly, I'm going to have a length here of minus 3. Okay, so this is purely an abstract case because clearly we can't have negative areas and negative lengths. So the area of my left-hand rectangle over here is going to be minus 2 times 2x, so minus 4x. And my right-hand one is going to be minus 2 times minus 3, so plus 6. So once again, my minus 2 times 2x minus 3 gives me minus 4x plus 6, which I suppose you can write more neatly as 6 minus 4. So that's what to do if I have an expression consisting of a single factor on the outside and a factor within the brackets consisting of 2 terms. What if I have 2 factors both consisting of 2 terms? So for example, x plus 1 times x plus 2. Well, just as before, I can write it out as x plus 1, x plus 2, and draw the lines just as I did before. Have to be a little bit careful to make sure I include everything and to think about what this means. It's saying I have x plus 1 lots of x plus 2. So that means I've got x lots of x, so x squared. I have x lots of plus 2, plus 2x. I have 1 lot of x, plus x, running out of room here. And I have 1 lot of 2, plus 2. Let's move this out of the way. So, not quite finished. Need to collect my like terms together. I've only got 1 term involving x squared, so x squared. I have 2 terms involving x. I've got 2x plus x, so that's 3 lots of x. And I have only 1 constant, the plus 2 at the end. Okay. As before, I can expand this by drawing it as a rectangle. I think I'm going to go underneath now. So I'm going to take my first term, x plus 1, to be the width, and my second factor to be my length. And again, I'll go through and find the areas of those rectangles. So x times x, x squared, x times plus 2 plus 2x, x times plus 1 is just x plus x rather, and plus 1 times plus 2 plus 2. So again, I get my x squared plus 3x plus 2. Now, where this is quite nice is later on in A level, you'll be doing polynomial division, and actually this idea of rectangles comes in quite useful there. But we'll cover that when we'll cross that bridge when we come to it. Okay, so my final example here is x minus 2 lots of 2x plus 3. Okay, so once again, we'll do it exactly the same way as we did before. We can do x lots of 2x, so it's going to give us 2x squared, x lots of 3 plus 3x, minus 2 times 2x, so minus 4x, and minus 2 times 3, minus 6. And once again, I collect my terms together. So I've only got one term of an x squared in it, so plus 2x squared. I have two terms of an x in it, a plus 3x and a plus 4x. So I add those two together, I get minus x. I don't want a plus there, I want minus x. And I've got a minus 6 at the end. And similarly, I can draw myself a rectangle, x minus 2. So again, with this strange concept of negative lengths, 2x plus 3, 2x squared plus 3x minus 4x minus 6. So once again, I get 2x squared minus x minus 6. Now, what you might notice, you probably noticed this during GCSE in fact, was in cases like x plus 1, x plus 2, where both of the x's in the two factors are unitary amounts of x, only one amount, when we expand it, our constant at the end is equal to the product of those two numbers, and our coefficient of x in the middle is equal to the sum of those two numbers. However, in the case like our second quadratic example, where we have a 2x and an x, or just one or both of them aren't only one lot of x, when we expand it, that's no longer the case. Our number at the end, our constant, is still the product of the two constants within the factors. However, our coefficient of x is no longer the sum of them. Okay, so what I want you to do now is pause this and go and have a go at exercise A. Okay, once you've finished that and you've checked your answers, press play again and we will look at some special cases. So, I'm assuming you've now completed exercise A, checked your answers, gone through, corrected any mistakes, tried to understand why you've made any mistakes. So, when expanding brackets, there are a couple of special cases, one of which is the perfect square. This goes back to the idea of being able to draw a rectangle. So, for example, for the first generalized example here of x plus a squared, well, if I square something, I times it by itself, so that's the same as saying x plus a, x plus a. So I can expand it. I could draw on my lines and do x times x, x times a times x, a times a. So you get x squared plus ax plus ax plus a squared, x squared plus 2ax plus a squared. Or, again, I can think of it, well, in this case, it's not going to be a rectangle, it's going to be a square, because both my factors are identical. So I'm going to have x and a, x and a, x squared, ax, a squared. So once again, x squared, 2 lots of ax, and a squared. So, for my numerical example, underneath, I have 2x minus 3 squared. So if you want to pause now and have a go at expanding this on your own. Okay, I'm assuming you've given it a go on your own. Let's see if you were right. So I've got my 2x minus 3. So if I want to try this out fully, I'm going to have 2x minus 3, 2x minus 3. And if I expand that by putting on lines, I'm going to get 4x squared minus 6x minus 6x plus 9, leaving me with at the end 4x squared minus 12x plus 9. Okay, hopefully you got that right. If not, go back, have a look at what you did, try and figure out where you went wrong whilst having this paused, and then come back to this. Okay, our second special case, difference of 2 squares. Now, why is this called the difference of 2 squares? Well, let's have a look at a generalized example at the top. I've got x minus a, x plus a. Well, let's expand it and see what happens. I'm going to have x times x, x squared, x times a plus ax, minus a times x, minus ax. Oh, hello. How do you cancel out? Minus a squared. So x squared minus a squared. X squared is going to be a square number. Regardless of what x is, I'm squaring it. And a squared is going to be a square number because regardless of what a is, I'm going to be squaring it. So I've got a square number, take away a square number, the difference of 2 squares. So looking at a numerical example then, I have x minus 3, x plus 3. I could go through and draw on my lines. However, I know, for looking at my generalized example, I'm going to end up with x squared, take away a squared at the end. So have a quick go at that. Pause this. Assume you've done that. Let's look to see if you're right. I'm going to have x squared minus 9. Okay. Once again, give this a pause. Have a go at exercise B. Check your answers, and then carry on with the rest of our videos. Thank you very much for listening. Hope it was helpful.